Let's get ready for your quiz tomorrow by working through some practice problems. So grab a pencil and a piece of paper and let's start. You roll a number cube 3 times and get a 1 every time. Is this possible? While thinking about this, every time you roll a number cube, you have a 1 in 6 chance of getting a number. So the probability of getting a 1 each time is 1 out of 6. So it is possible that we could get a 1 every single time. Is it likely? Well, again, the probability of getting a 1 is 1 out of 6. And getting 3 1s in a row, well, that's an even smaller probability. So we would say that this is not very likely to happen. However, it is possible. What are your chances of getting a 1 on the next roll? Well, remember, each roll is separate from the one before. Just because you got a 1 before doesn't mean the number cube is going to know to be a different number the next time. So the chances of getting a 1, the probability of a 1, still 1 out of 6. Make sure you're using probability notation, which is this piece right here, P1 equals, and then the probability as you're writing your answers as well. The probability of an event happening is 2 out of 7. What is the probability of the event not happening? Well, if I have a 2 in 7 chance that it will happen, then the remaining chances means it won't. So 5 out of 7 is my probability for the event not happening. So again, I'm going to say P not here equals 5 out of 7. What do the probabilities of an event happening and an event not happening add up to? Well, with the problem up above, you can notice that the chances of it happening, 2 out of 7, plus the chances of it not happening, 5 out of 7, makes 7 out of 7, or 1 whole. Or we could also think of 100%. So make sure when you're finding those two probabilities of an event happening or not happening, make sure they add up to 1 whole. Give an example of a situation where the outcomes are equally likely. We talked in class about flipping a number cube and flipping a coin, and so you might think about those. For example, I know with a coin, when I flip it, heads and tails, I have half a chance of getting each. I know with a number cube, I have a 1/6 chance of getting the numbers 1 through 6, if that's how the number cube's set up. But the whole point is, right, I'm equally likely to get each of those outcomes. You might have also talked about a spinner with equal size sections like red, blue, green, and yellow, and I have a 1/4 chance of getting each one of those colors. So now give an example of a situation where the outcomes are not equally likely. You might have thought about our cup from class when we talked about the cup landing on its end versus its side when we toss it. The chances of it landing on its end was around 1/3 versus the side was around 2/3, so those are not equally likely. You could also draw a spinner, for example, and I could have a section for red and a section for blue. Here you can see my chances of getting blue would be around 3/4 versus my chances of red would be around 1/4. So again, looking for something where the chances are not equally likely. What is a number that cannot be a probability of an event? Let's look at these examples: -1, 0, 1/2, 2, and 5. When I look at these numbers here, -1 cannot be a probability. Negative numbers will not work. Probabilities must be between 0 to 1. 0 is between 0 and 1, 1/2 is between 0 and 1. However, 2 and 5 are greater than 1. Those are not possible probabilities. What's the probability of an event that is impossible? An impossible event has a probability of 0. That means it's never going to happen. What is the probability of an event that is certain? If an event is always going to happen, it's going to have a probability of 1. That means it has a 100% chance of happening. You spin a spinner with 4 equal sections, red, blue, green, and yellow, and pick a marble out of a bag of 2 marbles, white and purple. Make a tree diagram and list all of the possible outcomes. I'm going to start by spinning my spinner. I have 4 possible outcomes: red, blue, green, and yellow. So I'm beginning with 4 branches. Then I'm going to pick a marble. So I will have a white and a purple coming off of each of those original branches. So red can go to white or purple, blue can go to white or purple, Green can go to white or purple, and yellow can go to white or purple. Now I'm going to list all of my possible outcomes. So again, I'm following through on the tree branches. So I could get a red and a white, a red and a purple, blue and a white, blue and a purple, green and a white, green and a purple, yellow and a white, yellow and a purple. Those are all my outcomes. And so you'll notice here I have a total of 8 outcomes. And again, I can use the counting principle to check that. There were 4 outcomes on the spin, and there were 2 outcomes on the marble. So 4 times 2 would get me to 8. What is the theoretical probability of spinning a red and picking a white marble? So probability of red and white, I'm looking up here, I see that there's 1 out of 8 possible outcomes. You do an experiment and get the following results. What was your experimental probability of spinning a red and picking a white marble? Well, I see here I have 4 total trials, so the probability of getting a red and a white is going to be something out of 4. And so here I see I have 1 red and white, and I have a second red and white here. So 2 out of 4, or 1/2. So out of my actual trials in the experiment, I got a red and a white half of the time. So why are there differences between the theoretical and experimental probabilities? If you will remember on the previous slide, we said the theoretical probability of getting red and white is 1 out of 8. But in the experiment, I got 1/2. So why are they different? Well, the theoretical is what we think will happen. It's what we expect based on the possible outcomes. However, the experimental outcome is what we actually get. It's what actually happens in the experiment. So again, distinguishing between the two, realizing that theoretical is what we expect or what we think may happen, experimental is what actually happens when we do the experiment.